In this class of Graph Theory Part 2, we will learn about some commonly used graphs like simple graph, finite and infinite graph, null graph, and we will also learn how to find out degree of a vertex in a graph. So let us start with a simple graph. Before starting simple graph, we will learn what is a loop. Edge whose endpoints are same vertex. Here you can see a vertex and one edge E1 is there whose endpoints are meeting at V1. So this is a self loop. Here you can see a graph. This graph is simple. So a graph that has neither self loop nor parallel edges is called a simple graph. In this graph, there is no self loop and no parallel or multiple edges. So parallel edges means what? That from, suppose I am taking vertices V1 and V2. If one more edge I will attach here like this. So this V1, V2, now it has two multiple edges. So in this case, this is not a simple graph. So a graph that has neither self loop nor parallel edges is called a simple graph. Next is finite and infinite graph. As the name seems, a graph with a finite number of vertices as well as finite number of edges is called a finite graph. Otherwise, it is an infinite graph. Here, you can see two figures are there. In the first figure, the number of vertices and the number of edges are finite. Vertices are V1, V2, V3 and V4 and edges are 7. So this is an example of finite graph. And in the second diagram, you can see that the number of edges and vertices are infinite. So this is an infinite graph. Next we have a null graph. A graph without any edge is called a null graph. It doesn't have any edge, only vertices are there. So here you can see three vertices are there, V1, V2, V3. So we can say this is a null graph of three vertices. So before knowing about some other types of graph, we must know how to find out the degree of vertex. So here you can see a graph. We'll find out the degree of vertex. The degree of vertex V in a graph G is equal to the number of edges which are incident on V. So here we have a graph with 5 vertices and 7 edges. We will find out degree of each vertex here. So degree of vertex V1. How to find out degree of vertex? So degree of vertex in a graph G is equal to number of edges which are incident on this. So number of edges incident on the vertex V1 is E5, E4 and E3. So degree of vertex V1 is 3. Now degree of vertex V3 is again, here the edges are E5, E4 and E6. These three are incident on V3. So degree of vertex V3 will be 3. For V4, again 3, E2, E7 and E6. 3 are incident on it. So degree of vertex V4 is 3. Degree of vertex V5 is just 1. Now we'll find out degree of vertex V2. Here you can see a loop is there. So the number of edges incident of vertex V2 with self loop is counted twice. So here this self loop is counted twice and edges E3 and E2 are also incident on V2. So degree of vertex V2 is 4 here. So this is how we are finding the degree of vertex in a graph. So we have a theorem. We'll do that theorem now. What is the theorem? Says that the sum of the degrees of the vertices of a graph is equal to twice the number of edges. So first we have to find out the degree of vertices in a graph, and then number of edges, how many edges are there in a graph, and then we will show that sum of degrees of the vertices of a graph is equal to twice the number of edges. So we'll consider a graph G with E edges and N vertices. Let those vertices be V1, V2, Vn. Since each edge contributes 2 degrees, the sum of degrees of all vertices in G is twice the number of edges in G. So if we'll take the sum of degree of vertices from I is equal to 1 to n, then degree of vertices dvi will be equal to twice the number of edges. So let us make it more clear through one example. We'll take the previous graph where we were having 5 vertices and 7 edges. We have found just now degree of vertex for each vertices here. So here we have a graph. Degree of vertex V1 is 3, V2 we have found to be 4, V3 is 3, V4 is again 3, and V5 is just 1. So let us find out the sum of degree of vertices. So it will be 3 plus 4 plus 3 plus 3 plus 1, that is 14. So 14 is the sum of degrees of vertices. And here we have number of edges 7, E1, E2, E3, E4, E5, E6 and E7. So number of edges are 7. Here we will see that sum of degree of vertices is equal to twice the number of edges. Sum of degree of vertices got 14 and that is equal to 2 into number of edges is 7. So both are equal. So we have seen with this example that sum of degrees of the vertices of a graph is equal to twice the number of edges. Next, one more statement we have here, that the number of vertices of odd degree in a graph is always even. If we consider vertices with odd and even degree separately in a graph, then we can write it as summation I is equal to 1 to n dvi is equal to summation dvj plus summation dvk. dvj is taken for the even one and dvk is taken for the odd one. So this, on taking the sum, it will be even. Being a sum of even number will get an even number. And we know that when we take the sum of odd number, it is also an even number. So the sum of even number and even number is again an even number. Hence we can say that the number of vertices of odd degree in a graph is always an even number. Next, we will go through the type of graph, that is regular graph. Now, when a graph is said to be regular, a graph is said to be regular if every vertex has the same degree. Now we know how to find out the degree. So here we have just one vertex here. So this we can say that it is a zero regular graph. On the second graph, you can say that degree of both the vertices is 1. So this graph is said to be one regular graph. In the third diagram, you can see a triangle. Each vertices is having degree 2. So this is a 2 regular graph. Here you can see the square or this diagram, in each graph, each vertex have degree 2. So we can say that these 3 graphs are 2 regular graphs. So because they are having same degree. Now let us go through few examples. Draw 3 regular graph with 6 vertices. If you have to draw 3 regular graph, right now we have drawn 0 regular, 1 regular, 2 regular. Now we have to draw 3 regular graph with 6 vertices. So you can see the graph here. You are having 1, 2, 3, 4, 5, 6. 6 vertices and 3 regular, means each vertex is having degree 3. So here this one is having degree 3. This is degree 3. This is degree 3. This is degree 3. This also has 1, 2 and 3 degree. This is also having 1, 2 and 3 degree. So this is a 3 regular graph with 6 vertices. Again, in this diagram also you can see that you are having 1, 2, 3, 4, 5, 6. This is not a vertex. So you can see each vertex is having 3 degree. These two are example of 3 regular graph with 6 vertices. Second example, draw 3 regular graph with 8 vertices. So here you can see the diagram. Here you have 8 vertices, 1, 2, 3, 4, 5, 6, 7, 8. Each one is having degree 3. That's why it is said 3 regular and the vertices are 8. So we can say the graph in which all the vertices of equal degree is called a regular graph. One more regular graph example is drawn here. The graph of 3 utilities is a regular graph of degree 3. Here each one is having 3 degree. Next is trivial graph. Trivial graph, a graph with one vertex and no edges, is called a trivial graph. Or a vertex of degree 1 is called pendant vertex or end vertex. Next is isolated vertex. A vertex V is isolated if it does not belong to any edge. Here you can see the graph. In this graph, V1 is isolated. So V1 is the isolated vertex for this graph. So today we have discussed about some commonly used graphs and we have discussed how to find out degree of vertex in a graph. Thank you.